All right. Okay, so just to be sure, Steve, can you hear me? Hi, Steve.
I'm here, Mo. I can hear you clearly.
Oh, nice, nice, nice. All right, so
Yep.
I think Bob is actually having some issues, I guess, with his
Okay, the internet.
phone. Yeah, not okay. So let's see. So there's an echo coming from Bob's end.
Is it still that bad?
Yeah, because I can hear myself.
No, that's serious.
No, no. I think maybe he has to just use some like a headset or so.
Yeah, yeah, Bob. Maybe you should just have to connect your headset, right? There's an echo coming from your end, so Chooks is also on the stage. Let's see if. Hi, Chooks.
Yeah, hi Marv. Good evening.
All right. Good evening. Okay. So let me quickly look into. I can see your message. This from Steve. Okay. All right. Okay. So Steve, let me just bring up what we are meant to work on today. Um, that topic was actually selected by Bob, right? Networking and communication. Uh, yeah. Speaking about TCP and UDP. So I actually wanted Bob to speak to that. But I don't know. Let's see if he has resolved this on his end.
This one. And this one is charging this one
Okay,
tomorrow.
Steve.
Mo,
Hi, Steve,
Mo,
can you
are
hear
we
me?
like?
Yeah, we're live actually. And
Okay,
there's a
okay.
there's,
I left a message. Did you see it?
oh yeah, yeah, yeah. I've seen it. That's fine.
Okay.
All right. Okay, Steve, Chooks, do you want to? Yeah, Chooks, can you hear me?
Yeah, I'm with you, Marv.
Okay, okay. Let's just have like a formal introduction, and yeah, we'll discuss we'll discuss on the topic of today, right? So just go ahead and introduce yourself, Chooks.
Okay, so my name is Chuk Sabanum. I'm a software engineer, also a network engineer. Currently, I work with Vent Africa, where we build crypto and crypto related products.
Awesome. All right. I mean, that's basically Jukes, the software engineer. I've been working with Jukes for a long time now. So yeah. I mean, you didn't say everything though, but that's fine. Don't worry. Over time, over time, the people listening will get to know you better. I'm sure that's what you want. All right. So I'm sure you saw the topic, right? Speaking of TCP and UDP. So yeah, maybe you want to give some background. Yeah, more like a description of these, protocols and what you understand about these protocols. Yeah, Chooks, in case you're speaking, you're muted. Can you hear me? You're on mute. Okay, I think Bob is still trying to join us again. Let me quickly try to. Hi, Bob. You're on the stage. Can you speak now?
Yeah, is there still echo coming from me?
Um, no, it's better. Yeah, much better.
All right, thank you. Good evening,
Okay.
Marv. Good evening, Tricks.
Yeah, good evening. Welcome. I was just
Thank you.
telling Chooks that you selected this topic specifically. So I believe you'll be, in a better position to actually talk about it, right?
Uh,
TCP and UDP.
okay.
So maybe you can just start off with an introduction of yourself. So yeah, just introduce yourself, please.
Yeah, in the presence of such great men, I'm just Bobby, and I'm in the tech space. That's as much as I'm going to do for that.
All right.
Nice,
Any,
nice.
anyways, I'll help you since you don't want to help yourself. Yeah. All right. So yeah, basically, Bob is a software engineer, right? That part is actually very important. And I work with Bob at Tech's Garage, right? So Bob has been, handling operations, but currently, working majorly as the CTO at Tech's Garage, right? Which is, of course, um, the organization handling this stream right now. So yeah. So, Bob, maybe you want to give us like a background, understanding about, those protocols, right? TCP and UDP.
Oh, okay. How do we start this? So first off, when you hear the words TCP and UDP, the first thing that obviously should come into your mind is networking. And within the networking, there's a standard called the OSI model, and this model is basically what describes how computers are supposed to be communicating over a network, be it the web itself or just two computers paired over probably like a local LAN. uh, Generally, the OSI model is meant to describe how these computers communicate. And in order to make it easy to understand these processes, it was broken down into layers. And there are about several of them. There used to be five, then it was increased to seven, I believe. Uh, I'm not going to call this in any specific order, but there should be the presentation layer, there's the session layer, there's the transportation layer, which is what concerns us the more right now. Um, that the transportation layer is where we would talk more about this TCP and the UDP. But then there are other layers. There's the network layer. There's the um, uh, Mav. Can you help me? I'm forgetting two of them also. Okay, there's also the application layer and the data link layer. That's the layer I was thinking of, and then the physical layer. Well, all these layers make up the OSI model, and I didn't call it in any specific order, but the area of interest for this evening is the transportation layer, and this is where basically the information that comes from one computer is packaged. If we are talking about it in logistics term, it is packaged, labeled properly, and sent over for transportation. TCP is one form of packaging of this information, while UDP is another form. Now, the TCP is in full is called the Transmission Control Protocol, and the UDP is called the in full is User Datagram Protocol. Now, just to give a surface overview of what the two of them are. So, the transmission control protocol is basically one that is connection oriented. By that, it means before messages are sent to the second system, there has to be a standardized connection. There has to be a pair before information is sent. It makes it in layman terms, it ensures that the data maintains a clear route and the data reaches its destination correctly. Let me put it like that. But the user datagram, in the user datagram aspect of things, it doesn't have to, fully be, it doesn't have to maintain a specific kind of connection. Data is just sent without proper packaging, let me put it like that, towards the direction where the other computer is. And when it is received, it is now debunked and added up to make the complete information that's trying to is being passed along. That's just the surface area. It's deeper than that. I would want maybe Chooks and Mav to weigh in on this. Am I alone here? Is my
Yeah,
connection
funny
still
enough, I've
good?
been speaking and I totally forgot I was on mute. Sorry about that.
Oh wow.
So
No problem.
yeah, yeah. So I mean, you pretty much give the I would say complete description as expected. I think that actually explains the protocols. So, but let's put it on the aspect of like engineering, right? Software engineering. So developers, who want to actually understand where this comes into, actual software development. Um, I have this on the screen. Can you see my screen? I'm actually
Let me
sharing the.
confirm that. Yeah, yeah, yeah. I could see
Yeah.
it.
Okay. So just like you described, of course, the physical layer, the data link layer, the network layer, transport layer, the session layer, presentation layer, and the application layer. So how does this, where would TCP and UDP, sit on this diagram?
Oh, the transport layer.
Okay. So if I am building an application, which is on layer 7, right? Um,
Yes.
how does that, how does the request, tend to communicate with these protocols that you have just described?
So basically, each of the layers work hand in hand. Um,
Yeah.
you build your application. Okay, probably given a foresight of what each of these layers do in the communication will make more sense. What do you think?
Okay.
Maybe
Okay.
that would help in the description. So the application layer, when as an engineer, that is where your entire application is your do I say the interaction with your application is. That is where communication between that's the human computer interface area of things. That is where communication goes between a person and the computer. So whether you are designing a messaging app or whatever it is, the application, the user interface where the person interacts with the application is at the application layer. Now, presentation layer is basically what I say like the schema in which the data is presented is used within the application, and that is what that is done. That does for the during the communication process. Now, the session
Yeah.
basically, when you are developing as a developer, obviously there are you create sessions in how do I put this? I'm looking for better words because English is far from me this evening, or terminologies are far from me. So I might be breaking a lot because of that. But I'm looking for words other than session to use. But basically, as an engineer, when you're working on this, there are aspects of your application that has to do with session management, and uh,
Yeah.
unknown to you many a times you are actually giving your computer instructions around the session layer. You are telling it, okay, when you get to the session layer of the OSI model, this is how I want you to handle things. So basically this maintains a session between me at this end of the application and the other person at the other end of the application. That's what that session layer does. It just tells them that this period in time that we are having this communication is happening within a specific session. And I'm maintaining this in mostly layman terms so that we don't get too technical just yet. I mean, we have Marvelous for that. Anyways, going down from that, once a session is created, the transportation layer begins to, package the data as we talked about earlier on, either in a UDP format or in a TCP format. This is something you specify, but most of the time we work with TCP based communication. That is what you easily find in majority of the application, because the TCP based communication usually it makes sure that each data is first of all broken down into specific pieces, and it is sent to a specific address. So most architectural designs that we have is usually is centered around specificity, if that is correct. But I believe you get my
Yeah,
point.
I get your point. Yeah, yeah,
Yeah, okay,
yeah.
but when using, there are certain architectures that you would want to work on that the UDP would be advised. If I'm not wrong, when you talk about buffering of messages, that is when a UDP design is mostly interesting, because at that point in time, what's your the first end of the application is doing is just sending multiple messages to something like a data stream that the other end is just first of all going to capture and organize before being used. But in a situation where each of the messages is used as it gets there, it needs to come in a specific order, then a TCP connection will be most required. So, but all that is done within the transportation layer. So, moving forward from there, the network layer is obviously it begins to get more physical at this point. It means you're now making use of your network points or your Wi-Fi connections. It's beginning to communicate specifically with the hardware. Now, I want you to note that the first three sessions are basically application based. It means you have a lot to do with it as a programmer directly. Coming down to the transportation layer, it has more to do with the kind of technologies you're working with generally, because once you start to deal with protocols, you are talking about standardization. So it is mostly built into specific or generalized utility based softwares that would be used while the communication is ongoing. And then from the network layer down is mostly physical. It has to do with the kind of hardware chipsets you are using, and the core physical aspects of your computer. So that is the network layer, the data link layer, and the physical layer. All these have, the network layer obviously establishes like sort of a physical connection with the other computer. The data link layer now goes further to the data that has been defined or tagged from your applications, from the first three layers, are now broken down in physical formats into the binary formats, and then they are passed through the physical layer to get to the other end, and the process is just reversed like that. So as an engineer, it's important that most especially the first three layers up onto the protocols, which is the transport layer, you are familiar with them, because it would make you more efficient with your architectures and your implementations generally. I hope I was able to play around the ideas well enough.
Yeah, yeah. I mean, I pretty much understand your explanation. That makes sense. So I'm going to ask this question. Um, right. So let's say on the application layer, of course, we understand something like HTTP. This is not very visible. Let me see. We can expand this. Let's go with 20. Let's go with maybe 28. I think that's fine. Um, 36. Okay. So you have HTTP on this specific um, layer, right? So let's assume as a developer, you're building an application, whether using WebSockets or using REST, for example. right?
Okay.
So
Yeah.
you build your application, to work over your regular, REST API, which is of course using HTTP. And when you send such requests, now let's just assume that we're now looking at this, from this. All right, so we're basically looking at building a streaming application, for example. Now, based on your
Okay.
explanation, we would of course recommend a UDP, right?
Yeah.
Because
Yes.
you're not really expecting that every single packet should be in exactly the same order. You're just publishing this, you're just sending it out, right? And you're expecting
Yeah.
it to, yeah, of course. So you're not really expecting a direct, feedback, unlike TCP, where there has to be this handshake to say I have sent the data, and the other party would say, okay, I have seen this, I have received this, right? So more like a confirmation. You understand?
Okay.
So now, speaking of this, this TCP and UDP, can you maybe just give us like an example, right? A typical use case, right, for TCP, and a typical use case for UDP. I,
So,
I mentioned streaming, but I want to like get probably more examples.
all right. For TCP, I would say a typical example is your daily usage of your HTTP, uh, which is your hypertext markup. Obviously, because
Yeah.
each and every data that comes is used in the specific order that they come. So it is usually very important that when implementing at that point, you use HTTP. So most almost anything that has to do with file that needs to be read. Uh, let me put it like that: file that needs to be read rather than, should I say, rendered. It's very important that it comes in that using TCP. So an example of that would be, your HTTP requests. It will be FTP request or SMTP. All of these that have to do with specific messaging that has to be organized in that specific order. You can't just send random data and expect it. It's going to cause delays. Not that it's not possible, but that would mean when the data is sent over, it needs time to reconstruct the data properly and ensure that there is no loss of data before it is interpreted to the user, which would cause lag and delay in communication between the applications. But for UDP, it's usually in cases of streaming and gaming, things that have to do with rendering most times, because when rendering, most times what is happening is that your application is building up sort of like so I don't know if you most of us would know much about pictures or videos, but what happens in pictures or videos is that your application uh, renders pixels in a specific order, and
Yep.
sometimes even when you lose some of those pixels, it does not affect the overall. Maybe it might affect in quality of the imaging or something, but it doesn't affect the overall. You can still get your message across. It's only going to now differ in quality. So applications like that, for the purpose of speed, for instance, YouTube, when you have a poor network connection, it still renders your images for you. Only that the image might be poor for a while because not all the data that is required to build up the final end product has been received. So in that situation, UDP could be used for speed sake. So your video is still playing while it is still rendering behind the scenes and ensuring that everything gets to together. So basically, in that situation, it's called a buffer. Data arrives, it is reconstructed, and it is being played in real time. So most applications that are under that category, like streaming and gaming, mostly works with things like UDP, while applications that would rather use the data as is when it arrives, it's advised to work with TCP so that it does not cause any form of delay or data loss.
Nice. Yeah. That pretty much explains it. So I think Chooks actually wants to add more to that. So Chooks, I'm bringing you to the stage right now. So just you know add more to what Bob has said already.
Okay, so yeah, basically, I think Bob pretty well understands what he's saying, and honestly, he did justice to it. But then I wanted to look at it from a different angle. Like, when we talk about TCP, when we talk about UDP, when we talk about generally what is being displayed currently, the OSI model, I mean, for viewers, what does it, how does it play out in your head? Where is this coming from? When we talk about networking generally, you are coming to an angle where these parts are very important. We're going to be discussing quite a lot around information and how you transfer this information. So uh, basically, there was a time in the world where uh, information were there, information were building up, but transferring this information was a problem. People had custom ways of doing things. Imagine you speaking your language, and even probably in your village or in your city or in your town, you have like every quarter or every district speaking different languages, and there was no way to really communicate and understand. In the computer world, it there was a time like that where computers could not truly communicate. So they needed protocols, they needed basically standards. Like people come together, a group of researchers come together and say, okay, let's do this, let's open up this standard. And when we need to do anything, when you need to build any system around data transmission, if you need a way for two computers to talk to each other, you have to implement it in a certain way for that to happen. And that gave rise to the OSI model that started from the physical layer to the data link layer to the network transport section, presentation, and of course application layer. And I trust that Bobby has done like quite well on this. He has already dealt with this. Then coming to the UDP and TCP, these were protocols that were developed at first when, especially at the early stages of computer networking and the internet. Not much was transferred. Most of them were just basic static web pages of few kilobytes. So it was fine to work with TCP, but let me explain it like to a layman, as simple as it can be, how a TCP works. So you both of us want to share information, and first of all we have to know each other. So if I want to send Marv a very beautiful and or let's say a hamper this Christmas, I have to know Marv's address, and planning to send that hamper, I can't send everything together because to the way the networking works, you can't send a bunch like the whole hamper together. You have to break them into pieces called packets. So then you start sending those packets one after the other. Whenever I'm doing that, Bob has to be ready. Bob has to sit in his house, and I will send one piece, probably a say a bottle of granite, and that's let's say that's fits into a packet, and Bob has to send me back an acknowledgement that yes, so I received the granite you sent to. I hope it's not only granite that is in this uh gift. I will say no, and I will send more. Okay, did you get the biscuit? He said yes, he got the biscuit. And he's not just asking that, he's also asking the probably you want to ask about the hygiene of these things I'm sending. Which method are you using to send it? Which route? Am I very sure it is passing the routes or the transport company? Is it GIG logistics that I used here, or maybe I'm using another type? They have to all agree at different points. And let's say for example I send a milk, and or say I send a flour. Mom, I'm going to send you a flour. So I sent a flour, and and one part of that flour is broken. You know, one of the petals is broken. Marvel, look at it. Chooks, this is broken. I don't know. It doesn't suit what we agreed that you're going to send. Then Marv will now discard it, will now throw it away. Please send me another flower, and I have to send another flower. Now, the most important thing to understand here is that with TCP, if TCP is very strict, so if everything that has been agreed on is not done, it means nothing is done. So imagine me sending, Marv all of this, and Marv has been waiting the entire day receiving of these packets, and it's just the packaging, probably the basket that was remaining for me to send to Marv, and Marv will say because I didn't send the basket that I didn't really send anything. That is how strict, TCP is. And this maybe this is very very basic. Like this is just an analogy, but then you can, when you compare it with how things move in the network, things work, network communications between computers happen in milliseconds, and sometimes microseconds. So you may not feel this, but even when you open a web browser, you click on a link, there are so many back and forth communication, there are so many syncs and handshakes and acknowledgement that are happening. So basically in the TCP world, you are dealing with a lot of sending of information, syncing with the from the sender. You, the sender, you have to sync really tight with all the protocols, all the communication. You guys have to agree on the language, you have to agree on the channel, you have to agree on some certain security measures that those files must have, or those packets must come with. Then you send it, and that person has to validate that yes, what has been agreed on, the established protocol standard has been met by that piece of packet. This happens when you open a web page. You see how your web page is loading and everything is streaming, pulling, trying to understand information that, like, the client, your browser, and the server is having the same thing. Computers are fast, so it's this analogy may feel weird. Like, does this really happen? Yes, it does happen. But then with UDP, when things, computers advanced, networking, large streams of data, in gigabytes came up, it wasn't efficient enough in some application to use TCP. We needed a faster way. Though it's more careless, but then it's quite faster, to transmit information. And UDP came, and UDP is telling me that, Marv, I'm going to be giving you this information in any order. When it gets to you, you do with it whatever you're going to do it. But of course, there are some protocols that are also sent. At least the sender and the receiver must establish, an address. This is where it's coming from, and this is where it's going. But it goes in no particular order. And the packets, this in this standard called datagram, they are self-sufficient to actually get to their destination, but then it's also not guaranteed, because for UDP they don't really care. Computers are good, but they don't really care if that information ever got to where you are sending it to. A good example that Bobby gave is streaming of video. Imagine if the technology of TCP, or the protocol of TCP, is employed in streaming videos when you're watching on YouTube, or as you're watching us live. It's not possible, right? It's going to take a lot of time. Like, probably will be 5 minutes ahead of you. You can't achieve that, live streaming with TCP.
Yeah.
It's not readily possible, because there are a lot of things that have to take place before you would acknowledge that, the recipient will acknowledge, or the application, your browser, whatever, will acknowledge that whatever we're speaking over at this end has been properly encoded, transmitted as agreed, in the right order, and is delivered to you in that right order. It's kind of having this information, break it down, send it in batches, well arranged, delivers to you, have to recompile in entirety before you can get this information as valid. Else it's going to be scrambled. But when you are watching us, sometimes your network will be poor, and trust me, some packets, UDP packets, are lost in the way. You didn't get it, or probably one of the layers of the internet protocol where you are connected to is broken. Some of those packets could be lost, and you just noticed, your network is not poor, your network is not bad, but sometimes when you are streaming videos and playing video games, you just notice that lag. Or for streaming, you just notice the quality drop. Things have happened on the way that caused that. But then you see, if you can imagine the amount of information or data that is being sent when you are streaming videos like this, It's crazy. It's a very wonderful technology, and that's made possible by things like UDP. I care less about how you get this information, but we are going to try as much as possible to send a lot of this information within the shortest possible time. And this is where these protocols come in handy. And in every day of our life, we practically use them. Sometimes we can't explain, how these things come about. But yes, there is a protocol, there are standards. This OSI model is the basics of every communication, starting from the physical to the application layer. These are the protocols that actually ensure that we are able to send information on both local and wide area network.
Awesome. I mean that was a wonderful, way to clarify, right? On these stuffs using, um, yeah. I mean using something very close to, I would say something relatable, right? So, yeah, yeah, and okay. So Bob was actually okay. So Bob, I saw your message in the private chat. Anyways, I won't say that. Um, yeah. Okay. So we currently have two people watching from YouTube. If you have any questions, you can drop your questions in the chat. But what I'm going to do is we're just going to rush through a very simple system design, using what we've learned right now, okay? Maybe for like 20 minutes or less. So I'm going to share a different screen. Bob, do you want to add anything to that while I share my screen?
I mean, he has given like a solid foundation. There's basically nothing else to add right now.
Okay. Yeah, so, all right, just give me a minute. Let us see. I actually wanted to do this on my Windows machine, but for some reasons I could not connect my microphone to that computer. Okay, so I have a practical example here. So this is a scenario, right? So we have a real-time multiplayer game, and I'm trying to build upon what you guys have described already. So the idea of having streaming or things like multiplayer, gaming, right? Real-time stuffs when it comes to UDP, right? Or TCP, basically making sure that the packets you're sending, of course, follows an ordered pattern, right? So ideally, these packets will be broken down, of course, right? I mean, this transaction you're trying to perform between two systems, of course, will be broken down into packets. On the TCP end, from what I've learned, based on this conversation, is that it has to be broken down into several packets, and it has to, be sent in an ordered fashion, to ensure that, on the other end, you should be able to compile this and, present it without having some sort of data corruption. Okay, so in this, practical scenario, this is a game, of course, Galactic Clash. So this is a real-time, strategy game set in space. Players build and manage their space fleets, and of course, they navigate through galaxies. Okay, and they engage in battles with other players. All right, so this game would, of course, rely on real-time updates and interactions between players. Right, so between the players' fleets, and it would also require a robust networking solution for smooth gameplay. Okay, so I'm not a game developer, right? Of course, I've tried and failed. I don't know about you, Bob. Have you tried and failed as well when it comes to gaming?
Yeah, I think everybody at one point has tried that thing out. But it's not everybody's calling.
Chooks, what about you? Did you try game development at any point in time?
Yeah. So what I just feel is game is not one of those things you do solo, right? If you don't have the
At
team
all.
set, just forget about it.
At
So I
all.
No, no, but we have solo game developers that are actually making it big time. I feel it depends on the personality. I don't have such patience, right?
okay, let's say we don't have such patience, but probably there could have been more games in the world if it was quite easy to start. I mean, I could be a
Yeah.
developer, but I can't tell a story. So how do I really develop games without telling a story? Bring in the audio. There's quite a lot, honestly, to build a real game that I would enjoy a minute today.
Yeah,
Yes,
yeah, yeah.
I know when you're saying there are people who build games on your own, it depends on the kind of game you're talking about, though.
Well,
So
okay, so I've actually seen there's this particular game I saw. I can't remember the exact name, but this guy did an amazing job. I mean, he started off alone, but after a while, recruited his friends. I think about three of them. But trust me, I think it's all about the personality and then the zeal. That you. I mean, come on.
the
Looking
passion.
at we yeah, because for someone like me, I'll be honest, right? I see it as you need to be patient enough to, spend a lot of time trying to achieve, something, um, something that I believe to me is not so. I maybe it's because I don't really find those kind of activities interesting, right? I think you should be a game person. You should love games, you know, um, before you can even get into game development, right? So you should love games. So for example, a regular software engineer can actually come into software engineering, because they want to make some money, right? So you can learn, you can code, you can make money. When it comes to game development, if you don't have that passion for building games, I don't know if it's something that would work for you, right? So just my thoughts. Um, all right. So some of the things I picked up before we start this design, when it comes to TCP, I picked up, the idea of reliability. So I'm just going to take down some notes here. When it comes to the connection, um, it has to be established, right? So I would say connection. There has to be an established connection. Let's say established, connection, which is saying that handshake you described, right? So from the sender to the receiver, okay. So there have to be an handshake, and I think the handshake is actually a three-way handshake. So to say, all
Yes.
right, I'm sending something, and the other end says, okay, yeah, proceed, right? And it will be like, okay, I'm sending it now, okay. So I think that three-way handshake is something we should also take note of here. So three-way handshake. All right. So, and of course, the third case here would be the acknowledgement, right? So acknowledgement, and yeah. So I would also write down something about UDP. I was actually taking some notes. So UDP, some of the benefits, of course, speed, right? So this guy is reliable in terms of the process, the order, right? And of course, telling you that if something goes wrong, I'm going to discard it, right? Yeah. But when it comes to UDP, the speed, of course, this is connectionless. So connectionless, it doesn't really have to establish that connection before transmitting the data, right? It just says, okay, I'm sending this data, you know, receive, or you can just choose to do whatever you want to do with it, right? So which means it doesn't expect any sort of acknowledgement. All right. Um, I want to be sure that my screen is being shared. Okay. Okay. Good. All right. Okay. So it does not expect any sort of acknowledgement, and yeah. So I think this is basically how I would describe this, right? So of course, you can use TCP for building things like interaction with your UI, right? Regular request response models, right? Um, and of course, UDP for video stream, gaming, something like YouTube, right? YouTube streaming. Um, yeah, yeah. So let me let's just quick one, quick one. When it comes to handling these, packet loss, for example, in UDP, since we're not actually we don't have to acknowledge. Let's say we're using this to build something like a VoIP, solution, right, for audio chat or video chat. How do you do things like error handling, Bob? If you can hear me, Bob or Chooks. So, like, when there's data loss, what is that? Is there any way to say, okay, we can actually resolve the issue of data loss, or it's something that has to be there? I mean,
Yeah, so
can you
UDP
can you
does
hear
not,
me?
yeah, UDP does not,
I think you
it
guys are
doesn't,
still on mute.
Can you hear me? Can you hear me? Marv, I can't hear you, but I'm speaking. Am I on stage?
Yeah, can you hear me now?
Yeah, I can hear you. There was a network glitch there, but I can hear you
Oh,
now.
okay, okay. Can you
Can
guys
you
hear
hear
me?
me? Okay, yeah, yeah, I can hear you.
Oh,
Yeah, yeah, yeah. I can hear you now, Chooks.
all right. So your question, how it manages.
Oh, I think it's my network then. Bob. Bob, can you hear me? Yeah, yeah, yeah. You're on the stage. I can hear you. Bob, can you hear me?
Oh, I could hear you. Is the lag from
All
my
right. Let me
end or
let me
your
drop
end?
a message in the. Yeah, I can hear you.
Okay, okay, that's fine. All
All
right.
right, I can hear.
I think we interrupted Tricks. Let Tricks just go ahead, and I think I'll come in afterwards.
All right, so can you guys hear me now?
Yes, yes, I can hear you now.
Okay, so UDP basically does not, it doesn't have anything to do with handling errors. Basically, I think that's one of the major challenges with UDP. Now, why we say UDP doesn't care about data loss, it's also important to understand that these data losses are not something that occur very often. So there are quite few times when these data loss occur. They do occur, but then systems have come very efficient that even UDPs are applied in IoTs today. So they are quite efficient. If you understand, the critical nature of IoTs, then you understand that it takes that level of trust and reliability to also employ tools like UDP. So though they can't do all of this error handling and they can't do all of this retransmission like TCP. So if anything goes wrong with the TCP packet, if it is broken or probably an IP is changed along the way, probably you switched a VPN or all of this. There are a lot of things that can go wrong in the way. A router could be broken in the network and things will just go bad. The TCP understands this that once a message doesn't get delivered, that if it doesn't receive an acknowledgement of a packet, it definitely needs to resend that packet in that particular order. But with UDP, it doesn't do that. So when a data is lost, it's just lost. It can be detected. It can be detected, though, because UDP does it still does checksum. The two standards do their checksum. So basically, every information that hits the recipient, they have to validate it if it's actually satisfied, if it's informed, it has not been corrupted along the way, or if it has not been tempered. But then there is really no way that a UDP does all of this. Like it doesn't really, do all of those data retransmission. It doesn't at all. Like it doesn't, and it doesn't acknowledge any packet received. So at both ends, I think there are trade-offs at both ends, both the client and the server end, or even both. If it's on the case of okay, client server then clients, they have to understand how to manage such systems. Like I said, when we are streaming, most sometimes very rare cases these days, but then your network will just drop. It completely has nothing. Your quality of your video could just drop. It completely has nothing to do with your network. In some cases, your network, I mean your internet connection to your ISP, or has to do with the transmission of those particular data. So the question is no, it doesn't really have anything. But then this occurs not really often, very rare cases that this data losses happen.
Okay. Okay. All right. That's basically what I wanted to figure out. Apologies, I dropped off the call. Um, yeah, I had some network issues on my end as well. So I got that. I got that. Yeah, while I was, checking out for some information earlier today, I was, trying to understand um, this error handling thing, especially when it comes to, like the packet loss on UDP specifically, right? I found out a couple of techniques such as packet reordering, um, or basically setting up some sort of redundancy, right? To basically compensate for the lost data. So I think if there's a way, right, to figure out that okay, some things did not actually get here, but of course there is not, you don't have that specific, mechanism built in because of the way the protocol works. But I think it's something, I would definitely um, delve into, right? Definitely after this call, especially something I saw from an engineer. I think an engineer working with um, YouTube, right? Mentioning error correction codes. So if there are some sort of errors, you are able to detect, and then um, I believe there should be, some ways to go around that, but it is not directly built into like, the protocol. So what I'm going to do right now, I'm
Let
sharing
me
my
just
screen.
weigh in a little on that.
Go ahead, please.
So in the area of UDP, Chooks mentioned something about the checksum, right?
Oh, okay.
And in the case of UDP, unlike the TCP that is much more meticulous with its checksums, it's not just that it's meticulous with its checksums generally. Because of the sync async sync, that's a three-way handshake. It is able to detect every step of the way, probably where the
Yeah,
specific error comes from. What
yeah,
happens in the case of the UDP is that it's basically like a full calculation that okay, this is the sum of the data that we'll be sending across to this end. So the receiving end knows the sum of data. So it just gives how do they call it now? There's a word for that. It gives like a generic information on the payload and the header. So each packet comes with a header that describes the destination and all that. Now the checksum contains the information about the header and the payload. So when the data gets to the other end, it's now when the checksum is calculated, if it doesn't match the original one that was intended, so there's just basically like an idea that there's a problem. But however, where the problem for it is coming from would not be stated. So it is now in the hands of the engineer to write at the other end that if you notice that your checksum doesn't come back correctly, maybe this is what you do. Maybe make a request for it again, or stuff like that. You would be the one to now start. Unlike in the case of a TCP where you could narrow it down to the main error and fix it down from there. It just gives you like a generic overview. It doesn't really give you like what the error is. I don't know if that makes sense.
yeah, yeah, yeah.
Yeah,
That
so,
makes sense.
that's just basically what UDP does. So the checksum comes with information about the headers and the general payload. So when it gets there and the checksum is recalculated and it doesn't match the original one intended, then okay, there's like an error with this thing. You really need to request for this again, or you need to reorder the way it's coming or something like that. So it's more in
Yeah,
the
yeah.
hands of the engineer.
Yeah, that makes sense. That makes perfect sense. Okay, so for this simple game here, I will try as much as possible to only speak to the infrastructure level. I won't talk about like specific gaming detail. I mean, that's not the point, right? So we are trying to see how we can, of course, leverage both UDP and TCP you know um connections, right? So for on the UDP end, we're going to be focusing on the streaming, right? And of course, the real time use case. And on TCP end, we'll focus on maybe configuration or settings management and all that within the game, right? But what I'm going to do is uh, I'm going to leverage a game engine. I found this game engine, of course, on the internet. So this is it right here, Photon, and yeah. So basically, this would the SDK would simply serve as our. Let me just push this to one end here. So we're going to be leveraging this in our design, right? And yeah, so let's just come up with a very simple design to describe how this game would basically be implemented. So all right. So this particular game engine, this can be deployed. The streaming aspect of this can actually be deployed, on the cloud, right? So we can have our game server, and we can also, leverage the Photon cloud to manage the UDP connections as well as manage the TCP connections, right? So let's just come up with a very simple sketch here. Now, remember the use case. Remember what we're trying to achieve here. Um, the real-time strategy game, and we're speaking of having multiple players, right? So, and there should be some sort of interactions, right? Between the players. So, for example, the game states, the fleet positions, right? You should be able to track the positions. We should be able to say, okay, we also need like in-game chats, right? We want to have like a chat to aid that communication, right? Yeah, we want to also track real-time, events. So, for example, we're taking down a particular fleet. We want to basically take this event in real time so that it can be rendered on both ends, right? So I'm going to group some of these things I just mentioned right now. Let me take them down first here. All right. So we're going to be, um, I'm going to group this into critical data and non-critical data. So yeah, non-critical data. All right. Okay. So basically, the critical data we're going to use, of course, TCP. Now, I believe this is, you already understand my rationale for this because we want to make sure that this information is actually captured, right? So we're not streaming this information. So an example can be, things like the profile, of these players, things like the game state, updates, right? We want to be able to track those details. When it comes to some of the things that we should, leverage the UDP modules for, that would be like the real-time event, as I mentioned earlier. Um, yeah, the in-game chat. Of course, I believe we can. Okay, no, let's talk about this right now. So for the in-game chat, I believe the rendering of this chat might be different depending on like the network of different parties. So I believe we can actually leverage UDP models for this. What do you think? The problem is, I mean, from what I'm thinking right now, some in case of like a packet loss or something, it means a particular message might not be, it's kind of like you're broadcasting these messages. Do you think we should be leveraging, regular TCP for this use case, or UDP for in-game chats? I mean, in my
Yeah,
opinion, I would actually say
TCP would
TCP.
make sense. TCP
Oh,
makes
okay.
more sense when it comes to messaging because obviously the data has to be used as is in its specific order. It's not something that you can leverage loss in data. So definitely it has to be TCP,
All
except
right.
it's a broadcast.
Yeah, but I mean, I think it's if you're saying broadcast, it means what we're trying to then say is that if there's a loss of message, it doesn't matter. But I think it should really matter. So
It should
we should
matter
leverage.
actually. So yeah,
Yeah.
TCP just it's TCP all the
Okay.
way. Yeah.
So we have the game state update. Please, you can mute yourself. Yeah, because of the background noise. Okay. So we also have the in-game chats as we just described. And yeah, so for the non-critical data, let's see some of the items we could have here can be, the real-time events, right? The real-time events. What else are we looking at here? Okay, the real-time events. Um, yeah, then if we're streaming, we should be streaming the fleet positions. Remember, because this is actually, if you're moving like those, of course, in the game, these things are going to be moved from one position to another, right? So if a particular player is moving to like, let's say position, let's say X50, Y58, right, on the screen, I think that is something we should be streaming because it is real time and it is happening at scale. It's not something static, right? The level of dynamism should be extreme, right? I can be here at this point, and in the next second, I'm here or I'm there. So I think it makes sense if we're actually streaming this at some point. If the other party's network or say something goes wrong and some packets were not properly delivered, it would update, right? So there will be an update. So you might not see it at position X 50 Y 100, but you should probably see it at position X 52 Y 102, right, on the screen. So I think using uh, UDP for this makes sense. Agree?
Yeah, totally, totally.
Okay. All right. So on the angle of the engine, right? Running this game, we're not going to build this. We're not game engine developers here. But since I have gone through the Photon cloud, and I have also seen a lot of developers or a lot of game developers actually use this. So we're going to be leveraging that for managing our game logic, right? In terms of um, yes, specifically for managing like the TCP connection. Um, I don't think that should not be for the game logic. So we should have our own like game server where we can deploy our game logic. So this will be for our game logic, and this would simply be for managing these. Let's see. So it's going to manage the connections. Okay. So managing the connections, which is of course the TCP connection and the UDP connections. All right. So while I was actually doing my research, I came across multiple gaming engines. So for example, let's see, some of the things I have on my list here would be I think the most popular one was Racket. Is it Racket? Oh no, I think it's Racknet, right? Yes, that was actually Racknet. Racknet, yeah, and I think it was written in C++. It's a C++ networking engine used for game development, and it supports both UDP and TCP, connections. It also provides a wide range of features such as object replication, voice chat, and network messages. But this has been, I guess, discontinued. Let me verify that as well. Yes, it was discontinued. Um, yeah. So which is why I did not, focus on using that. What I do is I look for, best practices and some of the modern tools, right, used by a lot of game developers. And this is Rocknet right here. Yeah. So it has been discontinued after 13 years. Okay. All right. So hence the reason why we are, leveraging Photon Cloud for this. So let me quickly come up with a sketch to describe, how this connection would look like. All right. So as I said earlier, we have the cloud, the Photon Cloud, and of course, the Photon Cloud will be managing the TCP and the UDP connections. We also have our game server. So this can of course be deployed on our own, cloud. It can be on AWS, GCP, or Azure, right? Or it can be on-prem if I mean, that's what is preferred. So we're going to have the UDP just to give a clear description of what is going on here. We have the UDP modules, and of course, the UDP modules will be managed directly because the Photon Cloud actually manages these connections. So let's just have a straight arrow doing this connection. We also have the TCP modules. Okay, so basically, remember I said earlier that the TCP module will be used for things like in-game chats, right? Also things like game status updates, right? And of course, tracking player positions. So let's just have some actors here. I'm going to have two actors. So I'm going to have player one, player two, or maybe let's just make it three, right? So we have player one, two, and three. So right here we have player one. We have. I'm trying to see how we can show like the movement or the connection, right? So player two, let's also have player three. Okay, so basically you want to be able to track, the of course, first of all, their profile. Now it is important that you have, uh, the profiles, of course, in terms of creating the profile, updating the profile, all the activities that happens when it comes to the profile, it should go through, TCP. Of course, this can be your regular, HTTP calls, right? REST and all that. Let's have our arrows, point down to this. So that should be a direct. Okay, that's fine. Next, of course, direct as well. Third one. All right. So basically, we are going to track the following. Let's point to this. So we're tracking the following. I would use a regular text for this. So this should be the player profile. And of course, under the player profile, we're simply looking at things like, updates, right? So it can be creating profiles, updating profile, right? All the necessary actions, okay? Deleting profile and all that. Deleting profile, okay? So we're basically going to perform all these actions, through, let's say, a module that we choose to call, player profile. And this, happens through the TCP, module, of course. Okay. And yeah, so this is going to be a clear way to manage TCP connection. Okay. Just give me a second. Give me a second. Yeah, guys, please just give me a minute, okay? All right. So sorry about that. I am still trying to fix my connection. All right. Sorry, please. Bob, can you still hear me? Hello?
Yeah, yeah, I could hear you. I'm hearing you clearly.
Okay. Okay, so yeah, I got disconnected and I just have to share again. Let me add this to stage again. All right. Yeah, I really apologize for that. So I was only trying to, yeah, I was trying to show here that we have the Photon Cloud responsible for managing these connections, right? So I think that was the last thing I was trying to show. So yeah, manage UDP connections as well. Now it would be a good one if maybe in the next session or something we can get to drill down into like the specific details about every single packet sent, right, whether TCP or UDP, and the exact details that are being tracked, right. I'm sure it would be an interesting conversation if we do that. So on the game server, we're basically tracking we're leveraging the UDP module, of course, right? So which means this is kind of connected to the cloud, right? So we're actually leveraging like the UDP modules because we want to track the non-critical data, as I said earlier. The non-critical data. Let's confirm what we have here. Okay, so real-time events, fleet position updates. Okay, good. All right. So using this, we can of course track the players, real-time events, as well as okay. So let's see. Okay, yeah. So the real time events, and of course, some of the events within the game that are not, very critical, even though they are not real time, right? So I can just refer to that just to make sure we don't have like the whole workload on one end. So we already know that the in-game chat. Let me take down some things here. So I'll say in-game chat, for example. This is directly managed by the TCP module. Um, yeah, what else am I looking at here? The game state, okay? The game state update. Let me drop this as well in game chat. Okay, and yeah, this is fine. Is there something I'm missing here? So let me say the non-critical game event and the real-time event. So real-time event can be maybe some sort of some sort of you know movements, right? Since we're going to be, moving, or I would call this streaming. If player one should be moving to a position, player three or player two should be able to, move to the same position, and of course see player one right there. So this is, of course, this should happen in real time. Okay, and yeah. So I can simply move this to a particular player, just to showcase that, we're simply speaking about the player right here. So I can say we're tracking real time events, right? And let's see. Okay, okay. I would say real time event and maybe non-critical. Non-critical because if something should go wrong with the data, it doesn't really matter. We can always, we always produce new data for that. So yeah, game events. Okay, that seems to yeah, that makes sense. So we have what else am I missing? Okay. Do you think I'm missing out on something here? So let's go back to this description. All right. So let's see if we're able to use the modules we have or the actions we have to accomplish what we have right here. Now remember I said this can actually be on like AWS, right, or Azure. And of course, if we're looking at the angle of scaling, right, these are the players. If we're looking at the angles of scaling, because we have let's say tons and tons of gamers simultaneously trying to access this server. This is the point where we can then choose to set up some sort of load balancing, right? So I'm just going to take down some notes, not necessarily draw rectangles. So I'm simply going to say for scaling, we can have multiple servers. So we can have multiple load balanced servers, right? So if this is on AWS, for example, yes, we can set up, load balancing, of course, while yeah, you can set up load balancing for this. This will be on Photon Cloud, so I'm sure this can scale. By default, this should have some auto scaling features, right? The only difference here is, of course, it scales according to your traffic, and then it should be some sort of subscription, maybe pay as you go thing. So based on the traffic or the workload, you pay according to the usage, right? And we simply have these modules, and at least we have been able to map out what the modules would do. So of course, from player profile management, game state updates, in-game chat, right, to ensure we are consistent with the order of the chats, as well as ensuring that the message is successfully delivered. And on the UDP module, we basically focus on tracking the real-time events, for the movement as well, like the positions and all that. So and yeah, we're also tracking some of the non-critical uh, game events. One thing I think I forgot to mention, but I said that several times, was the fleet position, right? So real-time events, fleet position updates, and non-critical game events. So I think this is fine. We've been able to actually capture some of these things. We did not speak, we did not specifically speak to, like, the server, the scale, capacity, network, and all that. We're just trying to understand, where the modules would, come in handy, given the set of given the requirement we have for the game. All right, and yeah, because of time, I think we can actually close out on this. But I mean, tell me if you think I'm missing out on something, or you have a question as regards, this simple flow. All right, Chooks, let's do that in maybe 2 3 minutes before we close out. Bob.
Uh, Personally, I think this is a workable overview of it.
Yeah,
Okay.
this works for me as well.
Yeah, so I think the only thing is maybe in a more detailed, view, we have to then dive into the specific, functionalities and maybe how to scale, some of
Yeah,
these modules, or probably what are even, how does these modules actually work in detail. I think we can actually discuss that in a different conversation.
yeah.
But yeah, I really appreciate your time, guys, and I actually learned one or two things from today's session. Um, yeah, so thank you very much, Jukes. Thank you very much, Bob. And of course, I can see Moses in the room, but he did not join the stage. Do have a wonderful night. Thanks for you know watching. For those of us that actually joined the stream, do have a wonderful evening, and we'll see you guys next time. All right. So
And thank you
yeah,
guys.
yeah. Bye. Thank you.
All right, bye. Good night.
All right. Good night.